Hello, today we're going to talk about PID, potential induced degradation. We're going to talk about what is PID, how to avoid it, how to fix it, and we're going to try to explain and clarify a bit of this very complicated topic. So when we look at the system, traditional system of inverter, and I'm talking about current string inverter, not in the past. In the past, we used to have transformer-based inverters. When we have a transformer, we don't have these problems because we can separate between the input and the output. I have the galvanic isolation of the transformer, and I can connect to earth the minus, the negative pole of the inverter. Today, with the new topologies, I don't have a transformer. I remove the transformer because I want inverter which is more efficient and also lighter in weight, cheaper in cost. I have transformerless topologies, and in these transformerless topologies, I have problems of very high and low positive and negative voltage in compare to the ground point. When I look at the string, somewhere in the middle of the string, it doesn't have to be exactly in the middle, it depends on symmetry, and if I have exact number of panels and all of them the same in both sides of the plus and negative poles, but somewhere in the middle I have some virtual ground. And compared to this virtual ground, the voltages here turn lower and lower, and the voltage more and more negative, and the voltage here turn more and more positive. And I need this negative and positive voltage in order to create the sine wave at the output, which is going from minus amplitude of the regi to the plus amplitude of the grid connection. So I have this minus and plus, and I need to create them from the minus and plus voltages of the input string. So we understood why we have negative and positive voltage compared to ground. And when I look at the panel, if I look at the panel, I look at the cross side of the panel, I see that the panel itself is isolated from the ground, but the frame and the backsheet and all what's covering the panel is grounded, is connected to the ground with grounding, whether through the construction or directly connected with a wire to the ground. And now I have potential difference between the frame and the backsheet of the panels to the inside of the panel itself. This is what is causing the PID, this voltage difference. Due to reasons of humidity and soiling, I have accumulation of positive ions, usually Na plus ions, over the top of the panel, over the glass, over the frame, over the structure. And these ions, because of this high field between the zero of the sides and the negative input, are pulled into the panels and creating this PID effect, which is practically reducing the potential. This is why it's called potential induced degradation. I have degradation in the panel functionality. Now, the more the panel is negative, the harder this problem. And I can see panel without a PID and panel with a PID, and the PID is actually degrading the cells themselves because of this penetration of ions into the cell, and I am losing the nice shape of my IV curve. Instead of having the nice IV curve I have in the origin, with time, the more and more PID accumulated into the panel, I'm losing my curve shape. I still have very close V open circuit and V short circuit, I short circuit and V open circuit of the curve, but the peak power is degrading with the more PID effect I have with time. When I look at the panels, the ones that are above the zero, the middle of the string, more to the positive pole of the string, doesn't have the effect because there is no negative field that will pull these ions. But when I'm getting to the negative side, the more negative I am, here I'm a little negative, I have a little PID problem. When I'm very negative, I have a lot of PID problem. And I can actually see this degradation like a ladder when you look at the curves of affected panels, you will see very affected at the negative pole, and the closer you get to the middle of the string, less and less effect, and in the positive side, you don't have effect at all. How can I mitigate or reduce the problem? So first, if I'm using good quality panels that don't let these ions penetrate, good encapsulations, they are called PID free. There is no real PID free, usually PID resistance panel. That means they have good encapsulation and it's very hard for these ions to penetrate the panels. Usually it's in glass panels or very good encapsulation, good isolation that doesn't let the ions penetrate from the outside, from the frame and the backsheet into the panel itself. The second thing I can avoid by trying to keep my panels clean with less soils and less salts on the panel. If I keep the panels clean, I have less chance to get the PID problem. I can also try to resolve system with PID by using anti-PID devices, or I can buy inverters that have these functionalities. For example, Huawei have an inverter that has PID reverse functionality inside the inverter, and this in the nighttime generate opposite voltage that is like pushing away these accumulated ions and discharging the PID and practically reversing the PID effect. The best solution would be using MLPE, using microinverters. When I'm using microinverters, I don't have high voltage because the DC voltage I have is only DC voltage of one panel or two panel. In these low voltages, you don't have the effect of PID at all because you don't reach the high negative multiple hundred of minus voltage that will create the PID at first place. So when you're using microinverters, it doesn't matter what panels you're using because you will not have PID problem at all. So these are the options to avoid or mitigate PID problems. Hope you learned something about PID in this training. Thank you very much.